everyone, welcome to our webinar today. This is Jill Hurston, Director of Marketing at CenterZip. I would like to introduce Mike Watson. He's our VP of Engineering at CenterZip. He will be our moderator today. Mike, I'm going to turn this over to you.
Thanks, Jill, and welcome everyone to today's webinar, Going Serverless with AWS, or actually using AWS in cloud, focusing on serverless. And today's focus will be a little bit more on the developer experience versus other sessions we've done where we've talked, more generally. So one thing I want to say about this is I'm a big proponent of serverless, and I have been for probably a year and a half at this point. And I think this is a really important topic, and it's a really interesting transformation in the industry. And it's, I think, a great way to build applications by focusing on what your company is good at. And certainly at CenterZip, we've been helping customers build their SaaS applications in this way. So recently, I also embarked on my own personal initiative to really understand what this means. So I went back to my developer days, became a developer, and wrote my own software, including building out the infrastructure using the CDK tools and end-to-end with testing, and really trying to figure out what that development experience is like. And it is different, and it is a little bit uncomfortable at first, but it's very powerful once you get the hang of it. So that's where this idea kind of came from. And we talked to AWS, and Taz has graciously joined us on this. So I'd like to actually hand it over to him. So here's Taz Miller, AWS Solution Architect and Presenter.
Yeah, hey everyone. Thanks again for hopping on today. Super excited to talk with you all. We'd love this to be interactive. So please, as we're going through things, post your questions in chat. Mike will be moderating. We'll try to get to those as we can. And I echo Mike's sentiment. I'm a huge fan of serverless. I think that it is a great way to increase your agile development. And there are a few points that, as Mike said, it's a little bit different. But hopefully today we can talk through some of those tools to make the experience as smooth as possible for you. And so today, some of those tools that we're going to talk about is obviously we have to talk about Lambda if we're going to talk about serverless. Two other areas that we're going to cover and show a few examples on are SAM and CDK, and we'll go into that a little bit later on what exactly those mean. For those of you who may be unfamiliar with what is Lambda, what is this whole serverless idea? I know when I first heard the term serverless, it didn't quite make sense to me because there has to be a server, right? Like we're doing something behind the scenes, and what we mean by that is from the user's perspective, from the developer's perspective. It's as if a server doesn't exist. We're able to take your process and basically offer functions as a server or as a service. So basically that means as a developer, you get to write your code and run it. You don't have to worry about managing your servers. You only pay for the compute time you consume, which means there's no idle time. If you're not running a function, then you're not paying anything for it. You have automatic high availability, and you're able to scale quickly with usage. Some things that Lambda handles is load balancing. Super heavy lift if you're managing your own servers. Easy with Lambda. It auto scales. You can handle failures. We'll talk about some of the processes for that. There's security isolation via IAM and role-based permissioning. You don't have to worry about your OS management. We take care of that for you, and also managing your utilization. So a lot of benefits for you. And this is, again, I think to reiterate, you're really just paying for value here. And so when we look through the building process, we talk a lot about the AWS Shared Responsibility model. So anytime you're building in the cloud, there's stuff that AWS is going to take care of, and there's stuff that you'll get to take care of and manage. And we have offerings all across the level of responsibility that you want to take on. So in the terms of compute, if you are looking to manage the networking, the OS, the virtualization, all of those types of things, There are options for you down at the virtual machine level. But what we found is most developers, honestly, they want to focus their time on innovating. They want to build the applications that are going to drive business revenue in the long run. Unfortunately, maintenance doesn't really increase the coolness of your app. It doesn't allow you to have a new product release. It's just, behind the scenes heavy lifting. And so that's where Lambda and things like serverless come in, is you can focus on what you want to do and what your developers do best. Another way of looking at this here, with just looking at the compute aspects of these, again, looking at the bottom with EC2, you're managing a lot, all the way up to the top of the stack, where really all you have to worry about is your application code, and there are some configurations that you have to deal with. What this does allow you to do is just rapid development. One example that I love to share is Coca-Cola. And so at the beginning of COVID, the world was changing, and Coca-Cola wanted to create a product experience where people could interact with their dispensers touch-free via a smartphone app. And what's amazing about this is they went from ideation to production deployment. They built this application in just 100 days. Think about that. This is not a small, just POC. This is 100 days, and now it is in 30,000 machines that have the touchless capability. That's what serverless allows you to do. Just super, super fast, rapid development. So what does that look like? That's what we've talked a lot about why you might want to do it, but what does it look like? Well, at the core, we have this thing called AWS Lambda, which is the ability to run code and not have to manage anything. And we support a bunch of different languages: Node, Python, Java, C#, Go, Ruby. I'm personally a Node guy, and so that's my preferred one. I've dabbled in Python a little bit. I know Mike, who's on the call, he's been dabbling with some of the others, has a strong Java background, and so it doesn't really matter where you're coming from. You can definitely use Lambda to program your applications. One thing that's different about the serverless mindset is the idea that it's event driven. And so, as we said earlier, when a function is not running, it's just sitting there and you're not paying for any kind of idle. So you need something to kick it off. And we have several ways to do that we'll talk about a little bit later. And then once you kick off the Lambda, you're able to do any kind of compute functionality that you want there. But it also links to over 100 AWS services, things like DynamoDB, Kinesis, all kinds of things. And so it's very, very easy for you to integrate with all the other AWS services that you're used to. Diving a little bit deeper into it, the initial setup might be a little bit different than what somebody is used to if they are a developer. At the core of Lambda is you have a handler function. And so this is what kicks the whole thing off. This is the core functionality. And again, we said earlier that this is an event-driven type of functionality. And so what that means is when you do initiate the Lambda, whether it be through a state change or even through like an API type call, that will be passed into this function as the event object. And so this could be whatever you decide to pass in as, a JSON type object. And then there's also a context object, which allows you to have methods available to interact with like runtime information. So you get things like your request ID, your log groups, and more things like that. Generally, when you're building, you're probably going to be focusing more on that event. And so in this example right here, it's fairly simple. An event gets passed in, and we return a body of hello world. It's as simple as it gets. And what's great is once you've done this, set a trigger to it, and it's ready to run and do whatever it is that you need to do. Super important aspect when you're building, of course, is monitoring. you need insight into what you're doing. It's great that, we can just kick these off whenever we want, but, we definitely want a Lambda console that allows you to see the latency and performance of your functions. We want to know if there were any errors or failures, any kind of throttles or anything like that. And that's what we have within the CloudWatch metrics section of Lambda, is it makes it super easy. You can go in there and see what's going on. This is good once you're in production mode, but also when you're testing. This is one of the first places I go to when I'm developing a new application and I'm running it, in the cloud, is I'll run it and then immediately go and check those logs. Via log statements, you can do a ton of debugging and really understand what's going on behind the scenes. One area that I want to touch on just briefly is Lambda Layers. With layers, you're able to upload code once. So these are your own maybe custom libraries or runtimes basically that you want continued access to. So you're able to upload it once and then have it used by multiple Lambdas. And so this can be super useful to customers who need something like that. So if you do have custom code that you need to use more than once, this is how you'd want to do that. And you can bring your own runtimes as well. So with C++, Rust, PHP, those types of things. And so definitely something to keep in mind.
So Taz, just following up on that. So what you're saying there is if you have C++ functionality, you could put it into one of these layers and have your Lambdas access it.
Sure. Yeah.
Nice.
Yeah, and that can be, that can be great if you are looking at that low level of programming. Maybe, your developers spent a lot of time coding in C++, just getting real low level access to that compute power. You want to reuse that stuff. And so moving them into the layers will allow you to take advantage of both worlds, take advantage of the work that you've already done, while also taking advantage of the agility of something like a Lambda function.
Awesome.
Yeah. So there are a few, as I mentioned, this is all event driven. And so there are a few different models that we have for that one. And I'd say for me, at least, the most common is the synchronous / push model of building. And so this is, you have a front end website that you've, made in React or something like that, and you need to execute something in the background. Well, using API Gateway, you can make a path to that, and then as soon as a user hits that path, it's going to trigger some kind of Lambda function behind the scenes where it can go do database calls. It can do, just generally whatever it needs to do. Another common area that we use is through asynchronous type events. And so, if you have like SNS where you're regularly publishing to a topic, or maybe you're regularly pushing objects to an S3 bucket, you're able to take those events, and as they come in, we're able to handle those, and you're able to scale up those Lambdas accordingly. And then the last, which is becoming very common, is pull-based streaming applications. So integrating with things like Amazon Kinesis so that you can analyze changes in your streams, have that be passed to Lambda, and then be able to take some kind of an action off of that. That can be super useful. And there are a ton of ways that you can trigger these Lambdas. From data stores, we can be looking at changes in that. If someone updates your DynamoDB, maybe you want to trigger some kind of application. Someone uploads a new file into S3 that you want to change the resolution or something like that. Easy to kick something off. Within configuration repository, so like, this is your cloud management tools. Maybe something happens in CloudTrail and you want to automate a response to that. Very easy to do with Lambda. You just look for that event and have that trigger a Lambda to make some kind of a change. Of course, we have endpoints. I've worked most with API Gateway combined with front-end development, but you also have endpoints for things like IoT devices. We'll talk about step functions a little bit later. And then you also have event / messages services. So these are things like your simple notification service and also cron events. Sometimes you just want something that runs regularly. I was once working on a project where we needed to update pricing information of something that was being advertised on a website. And unfortunately, that information was not being stored in something like S3 or Dynamo. And so, we ran into this problem. Like, we want to be able to regularly update, but we don't actually have access to those events as they happen. A cron job was perfect in that situation. Essentially, because of the business needs there, it only needed to be checked basically once a day. And so what we did was we set a cron job, super easy. It kicked off once a day. It hit the external API, pulled that information, and was able to make the necessary updates to our front end or to our storage layer.
Yeah. So one interesting thing I've seen, Taz, is using Amazon DynamoDB streams to trigger events into like an SNS queue and take those events and process them downstream. Either you could warehouse them or you could do other post processing. That was really good pattern that I saw implemented that worked really well.
Yeah, absolutely. And I think what I love most about this is you can escape from kind of the always on mindset. The Lambdas are only going to run when they're needed. And I think that's really fantastic, honestly. It's super cost savings for you as well. Now, one thing that we do need to acknowledge is I've heard the saying, everything always breaks. And so you should build with that kind of a mindset. Build knowing that things will occasionally break and have automatic handling in place so that you're able to handle those types of things. And so essentially what you have with a dead letter queues within Lambdas, Lambda will attempt to run a function if it does fail an additional 2 times with a 1-minute wait time between those first 2 attempts. This can be really great for, again, with that previous example that I was talking about, where we're querying an external API. Sometimes we don't have control over the traffic going to that API, and for whatever reason, it may be overloaded. Having the built-in functionality to stop, let's wait a minute, and then resume is super important. There are other ways that I've seen this done as well. If I can take a tangent for a second, that's pretty interesting. Where basically, again, we're querying a third-party API. Unfortunately, sometimes that may be unavailable for whatever reason. And Lambdas, as we talked about earlier, have the ability to scale very, very, very fast. So let's say you've got a queue coming in of requests. Lambdas are going to scale up, so you have hundreds of Lambdas maybe running at once, all querying the same API. That could very, very quickly overload something. And so what's great is you can actually put a middle layer inside of that. Something like DynamoDB is what I've seen. What's cool about this is you'll first have one function essentially that is kicked off by a queue or by a cron job, which will first just do a soft query on an external API, record that information in DynamoDB, that result, and then based off of that, it will determine, should I run this again immediately, or should I maybe wait 5 or 10 minutes or something like that? And so there are ways to handle these types of things in addition to just the dead letter queue. There's a lot of creativity that can be involved, and that's why you do see a ton of Lambda use cases. Web apps being the one that I have the most experience with. You have mobile and IoT backends. That's super great. Mike, you kind of mentioned it earlier. Real-time data processing, chatbots, Amazon Alexa, IT automation. There's all kinds of use cases, and so let's look at just a few of those here. So the first one, probably the most common idea, is you have some kind of a file that you want to do something with. Maybe it's an image that you want to do some kind of image recognition on. Well, that's super easy to do. You set up a trigger, the image is uploaded, maybe it's a picture of your cat, maybe it's a picture of a dog, and we want to know what it is. Well, put that in S3, that'll kick off a Lambda, which can then, as I said earlier, it integrates with a ton of services, so it can easily call the recognition API, send that image there, let it get analyzed, take that request back and send it to wherever it is that you need it to go. Super common use case there. Again, data publishing to some kind of an SNS topic. You want to analyze that data really quickly. Maybe this is this could be anything. It could be if you're receiving things from people texting or emailing or something like that. You may want to take automated actions based off of it, or maybe it's even an internal process that something has failed, and so you publish that failure to an SNS topic. That could be something as well. You've got queues based off of SQS as well, where Lambda will pull the queue and invoke a function, which then after it's successful will remove that from the queue. A few other options. Again, data.
Taz,
Go ahead. Yeah.
Taz, I have a question. Like, what is the high level difference between SNS and SQS?
So the biggest thing is SQS has that ability to go in there and you're able to remove things from the queue, and you have options on how that queue is set up. Generally, it's a first in, first out type of a situation, but it's able to keep a closer track on the completion of whatever task it is that you are looking to accomplish.
I see. So it just has more advanced queuing capabilities.
In this context, sure. In this context, you can go very deep into the differences, but I think when it comes to just Lambda polling type things, it's a little bit more also reactive. For SQS, it's the Lambda itself is a little bit more proactive because it's going out and kind of reaching out to that SQS and trying to take action on that, whereas the SNS is more proactive in this case. It is nuanced. I will agree, but I think when you're thinking about which one to go, I tend to think, do I want to do things and be able to track the completion of those things in some kind of an order?
Gotcha. Okay, thanks for that.
Yep. Next, we have Amazon Kinesis data streams. Similar in some cases to the idea of the SQS SNS. It's just you're going to be able to do this at higher scale. Chatbots obviously make sense why you'd want to do that there. And again, cron jobs. You want to go do something, you have that opportunity to do it. And so here's an example of some real customer examples of some people who have done this. The Seattle Times uses AWS Lambda to resize their images for viewing on different devices. And so all that has to be done is you take a photo, you update that you put that in Amazon S3, which triggers a Lambda, and then it will automatically create your mobile, tablet, desktop type size of files. Super hands-off. And what's great about this is you don't have to wait around for something to happen. It's just when you're ready to resize those things, it'll happen automatically. Going again, another common use case, we talked about Kinesis several times, is Localytics. They actually process billions of data points in real time using Lambda to process historical and live data stored in S3 or streamed from Kinesis. And so very, very high scale that you're able to, and in this case, you can create social media trend data, which is immediately available for business users to query.
So in that last case, the advantage of this particular set of technologies is they scale automatically, right? So as the demand increases, they all scale without any need to, I wouldn't say any need to worry about it, but like it's all taken care of by Amazon and the serverless realm.
Yeah, that's a good point to call out. So there are service limits that I would recommend everybody go and check those as you're trying to build out this application. Go check those service limits, and sometimes you may need to put in a request to maybe raise those if needed. But generally, yes, this will scale from I like to say it goes from 0 to 100 real quick. And what's nice about it is you don't have to make those decisions on your own. It's ready for you. It's ready to go. Here's some talking about scale. How big can this go? Well, we have Thomas Reuters, who does 4,000 requests per second. It's pretty fast. Expedia triggers 1.2 billion Lambda requests each month. FINRA processes 500 billion validations of stock trades daily. And Fannie Mae scaled up to 20,000 concurrent Lambda executions in testing. So that's some fast scaling and some very, very high scale. And so for most business use cases, Lambda can be a great option when you're talking about scale. But as much as I love it, as much as I love Lambda, there may be the occasional appropriate choice where you may want to choose one of the more traditional methods. And so I do want to address that for a second. If you want to configure servers, storage, networking in your OS, if you want access to specific storage methods, maybe GPU, those types of things, the Amazon EC2 is going to be the best option for you there. If you want to run and manage your servers, but also run containers on top of that, ECS is a great option. If you don't want to worry about the server management, but you still want to take advantage of the benefits of using containers, AWS Fargate is a great option for you there. But for a developer who's just, they don't want to worry about any of that other stuff and they just want to write cool code and run it when it's ready, AWS Lambda is going to be a great option for you there. Another call out here is going into the kind of differences between a Lambda serverless versus a container serverless, which we call Fargate. I think one of the biggest differences is how long-lived the Lambda will continue to exist. So Lambdas are a different programming mindset. These are not meant to run for hours and hours doing stuff. If it is running for hours and hours, you're probably building it incorrectly from a Lambda perspective. You may want to take a step back and think, how can we make this more of a microservice? How can we take this big process and turn it into little pieces that are faster to run? There are some situations where that may not be possible, and that's where something like AWS Fargate or ECS comes in, because you can have more long-running processes for yourself. And if you do have an existing code base, for example, or an existing container repository, Fargate is another good option for that to make it easier to migrate into the cloud. Here's a great screenshot. Again, you guys will get this presentation afterwards, but I love this rough guideline for trying to decide what you should use between Lambda and a containered service. And what it really comes down to is how much memory do you need? How much time do you need to run whatever function it is you're running? Those are probably the two biggest considerations. And the last thing that I want to talk about when we're comparing and contrasting the different options is, where is the break-even price on Lambda? Well, because you're paying per request, it's a little bit of an anti-pattern to have a Lambda function running at, or multiple Lambdas running at scale 24/7. The price can add up a lot, and it honestly, if you have compute resources running 24/7, something like a container or a virtualized EC2 instance might be better for you. Taking a step back though, it's really hard to make these calls. It's surprising the results that you can come up with if you actually take a second to step back and test. And when people ask, which will be more expensive, a Lambda solution or maybe an EC2 or container solution, I think the best way to do it is to run a real-time test to better understand your traffic and usage. And what's cool about this is Lambda has a very robust free tier. And what I mean by that is the first 1 million requests are going to be free for you. And that includes up to 400,000 gigabytes of compute resources. And so if you're ever in a point where you're not sure if it's going to be cost effective or not, to split things up, turn it into Lambdas, just give it a test, or always reach out to a solutions architect. That's what we're here for, is to have those more in-depth conversations with you all. And one last thing on this, as we're considering cost, because I know that that's a huge concern for a lot of people, is there's cost for the compute resources, but there's also cost associated with maintenance. And you have to remember, when you transfer to something like Lambda, you're taking away auto scaling, high availability, failure handling, OS management, and all of those types of heavy liftings that are usually taking up your developer's time. And so that's something to factor in to your decision making, is how much employee man hour or just employee time is spent on managing these types of things.
Hey Taz, I have a couple points to add in here. First of all, we're working with a client, and we have been for quite a long time, where we sort of went from lift and shift to containerizing to moving to Lambdas over the course of our involvement with them. And it's really helped a lot. Like when we actually eventually got to the Lambda-based solution, like the cost went way down, as you're saying. The cost to manage, the people cost around managing, and it's been a great benefit for that client. So we've seen this work in action. We've made it happen in conjunction with that client. It was quite great. The second point I want to make is we are doing a webinar on the topic of Kubernetes versus serverless, or containers versus serverless, next month. So I urge everyone to look at the synerzip.com website and go to the webinars section and check that out, because I think this is a really compelling topic. It's like, when is the right time to use one thing or the other? And hopefully that webinar will help us all figure that out better.
Yeah, absolutely. I'm looking forward to that webinar. I'll probably have to go and sign up for that so I can listen in as well, because it is such an important topic. And it's not always a clear answer. And another thing that I like to point out to people is we often approach this containers versus serverless thing like we have to choose one or the other every time. Sometimes the answer is, well, why not both? Sometimes a single application or a single business application may benefit from both. And so that can be a really great topic. I'm excited to hear more on that. And so the next thing is we've kind of talked about like all we can about Lambda, but how do you get started? What does this actually look like to the developers out there? Well, it's pretty easy. You navigate to the AWS Console, you click Create Function. You can use a blueprint. So we have several that are just basically boilerplate code ready for you to give a shot and edit yourself, or you can start from scratch. Go ahead and name it, give it a runtime, and you can start writing your code. There's actually an in-browser code editor for you to use up to a certain size. I do want to call that out. Certain Lambda functions become too large for the editor to load all the code, but for just getting started, using that is a great option to just play around. You can set your memory size.
That just triggered a thought. So you were talking about runtimes and what I've used. I chose to learn JavaScript and use Node as part of my project, which added a lot of extra overhead for me, learning a new programming language at the same time as picking up these things. But it worked quite well. I was very happy with it.
Yeah, that's what I developed most of my Lambda project in, is Node. And honestly, the main reason why this in-browser editor may become overwhelmed is not necessarily because of the code that you are writing, but if anyone who has developed Node for too long, dependencies and the size of a Node app can grow very, very quickly with a single npm install. Sometimes you're getting a lot of material out of that one simple terminal call. So that can load it up. And in those cases, just take it over to your preferred IDE. Once you have some code in place, go ahead and choose how much memory or how much CPU that you need associated with that, and also a timeout. This is a great area for cost saving, is making sure that you've played around with these and tested to know which amount is correct. I know in my early days of playing around with this, I was trying to figure out why did my Lambdas continuously fail. And the reason why is because I had my timeout down at, I think it was 2 seconds. And unfortunately, the complexity of that application just meant that I wasn't able to query an external service and get a response back within 2 seconds. And so of course, everything was going to fail. So you can change those timeout numbers according to your needs. And for memory, you can scale up from 128 megabytes up to 3 gigabytes. And so once you've done that, once you've kind of got all the bones ready to go, you can add a trigger. This can be, again, CloudWatch logs, S3, cron job, all kinds of things. After running Lambda for quite a while, we started hearing several requests from our customers, and they wanted to sequence functions. We heard from them that they wanted to select functions based on data. They wanted to run them in parallel. They wanted to have retry functions. They wanted try, catch, finally type functionality, or they wanted to just run their code for hours. And we heard that response. That's where we created AWS step functions. What this allows you to do is to coordinate and visualize Lambda functions as a series of steps to create serverless apps. And so as you're playing around with step functions, you'll actually be able to see the projected workflow for how you're going to move data between different sources. It's great because it allows for automatic, you're able to automatically trigger and track each step at scale. And you can change and add steps without writing code as well. And so this is a topic in and of itself that I think could deserve its own deep dive. But I wanted to talk a little bit more of, again, we're here as developers. We want to get started on this. How can we do that? And one of the first tools that I want to talk about is AWS Amplify. And it is probably the fastest, easiest way to build mobile and web apps that scale on AWS using serverless. When we go through a few of these different tools, I think it's important to think, okay, which one do I use where? If you're thinking mobile development, or you're thinking that you're going to be doing front-end web apps, Amplify is going to be a great place for you to get started on that. And the reason why is what it does is it provides you, using this example here, Amplify auth. It's as simple as downloading the CLI tool, running Amplify add auth, which will then create a CloudFormation template. And for those not familiar with CloudFormation, CloudFormation is our infrastructure as code. It's YAML or JSON-based configurations that we can push into the cloud, and it'll provision resources for us. And so when you do Amplify add auth, it'll create that CloudFormation template for you, as well as provide front-end code for you to be able to very, very quickly create an authorization box. It's honestly just very, very easy. And we have pre-built components for React, Vue, Angular, and React Native. So most of the hot front-end programming libraries at the moment. And so what's cool about this is with really very little coding on your side, you're going to create a front-end application that will front-end authorization component that handles sign up, sign out, password user management, and other common auth workflows. And so definitely if you're doing some front-end or mobile development, I'd recommend looking into Amplify. There's also a great console type point and click way of interacting with things as well if you're not looking to get so deep into the code. For those that are looking for a little bit more control, and maybe they're not looking to do front-end work at all, the Serverless Application Model, or SAM, AWS SAM, is a great tool for you. A lot of people get confused between what is the difference between CloudFormation and AWS SAM. Well, there is a lot of overlap. And the reason why is because they're both configuration management tools. The reason SAM is so beneficial is that it really focuses specifically on serverless. And so it has the tools required that you need to build in the cloud, but it simplifies it down a lot. Another thing that's great about it is it's also open specification. So you're able to go in, take a look at that code. And I want to show you on the screen real fast the difference here. So on the left is a CloudFormation template example for just an API triggering a Lambda. On the left, that's what you're going to have to do if you want to do it manually through CloudFormation. You're spinning up a lot of code, and that can be pretty complex. If you decide to use the AWS SAM example, it's much shorter. Essentially, you're just going to say a get HTML function, name the handler and the event type, and we name it as an API. We give it a path. It's honestly just that easy. You just kind of have to mentally think through what is it that you need and then define it there. And there's some great documentation for that. But this doesn't cover my favorite aspect of SAM. One of the things that was tricky initially for me when I started learning how to program in serverless was, how do I test this stuff? How do I make sure that this is working? Because as you progress, you definitely want a CI/CD type situation where you're pushing your code, which then updates the Lambdas and everything like that. And that's great. But sometimes you just want to test locally. You don't want to have to go through that whole CI/CD process. And that's one of the things that SAM allows you to do. So I've got an example here that I want to show you all. So essentially what we're going to do here is we've got a template that we've defines this function, and then an event.json. So this is what's going to be passed into that event section of the function. And so in this case, we were just saying name equals Bob. And so here we're just finishing out writing the rest of the function, just a simple hello world, or hello Bob in this case. And then bringing up the terminal, all you have to do is call SAM local invoke. And in just a moment, you'll see on the screen that it'll return a hello Bob, exactly what we were looking for. So at no point did this have to go into your cloud account. It's going to go again as I talk through this. But you didn't have to open up the console. You were able to just run that locally and see how it works. And when I saw this, I was like, oh, this is great. You know, I can run a function, see if my functions are working, but it wasn't quite there, because I want to know, like, if I'm testing from a front end, like I need actual access to an API, so that I can test, you know, are all of my pieces playing together nicely? And that's what this next area comes in. Again, we're using that SAM template. All we're adding here is some events, and so we're doing the API type event. And what we can do is SAM local start API. And what's cool about that is it'll return a path for you all to access that. And as you can see here, it's implemented. That API is running, and it takes it one step further, which is pretty cool. And so we're going to put in a couple extra steps other than just a callback saying not implemented. And after save, we can go back, refresh our page, and it supports hot reloading as well. So there's some really cool options there for you. So you don't have to, if you're developing and you want to keep going and you just want to test locally, the SAM toolkit is going to be really, really useful for you. Next up, a topic that Mike and I talked about before this webinar that we both are fans of, which is the AWS Cloud Development Kit. So like, let's take this one step further. We don't even want to mess with the JSON or YAML templates of SAM/CloudFormation. We just want to write code like we're used to as developers. Well, that's where the CDK comes in. It's open source, and you can do things in again, several languages. We got support for Python, JavaScript, TypeScript, Java, or C#. And what's cool about this is you're actually able to define resources in the cloud, just like you're coding. For those who are developers and coders on the line, this should look pretty readable to you. You know, in this case, we're defining a VPC, we're defining a cluster, a service, and what's cool is you can interact with things just like you would a normal coding language. What I like to say sometimes is the CDK is in some ways CloudFormation, but with for loops. And so, you know, if you want to dynamically allocate new infrastructure based off of something, you can totally do that here, and you can have actual programming logic there. And what's neat about this is, let's say you want to use the CDK because it makes more sense to you as a developer, but you still want the testing aspects of SAM. Well, they're absolutely designed to play nicely together. And so you can totally run code, or you can manage your infrastructure using CDK, but use some of the great testing features of SAM to be able to test those Lambdas locally. And so huge fan of the CDK, and definitely encourage everybody to go take a look at it. It makes it so easier. It really blurs the line between infrastructure management and just traditional development.
Going back to the CDK, yeah, I really thought the fact that you could develop as a developer and not as a YAML construction engineer made a huge difference
Right.
for me personally. Now, the interesting thing, one little tidbit for everyone is this actually spits out YAML, right? Like you run this code, it spits out YAML, and that's what's actually used. So when you're debugging this, typically you go look at the YAML to see why something didn't go right. At least that's what I figured out.
Yeah, that's a fantastic call out. So basically what you're going to do as you're working with this is you're going to synthesize the code that you wrote, which does spit out those YAML docs. And so, yeah, I think that's a great call out. Is if you're ever curious, like, wait, why is this not running? Like, what is this code actually creating behind the scenes? Well, it's CloudFormation templates. Behind the scenes, we're still going to use CloudFormation because that is the tool that we have to manage infrastructure as code. This is basically a translator to take it from the code that people are used to writing and turning that into CloudFormation. So yeah, absolutely. Debug in both places.
And I haven't used SAM personally, but I've used, say competitor options out there. And I'm sure it's doing the same thing behind the scenes, right? So you get that simplified kind of view of the CloudFormation constructs, but it, ultimately is going to spit out CloudFormation and upload it.
Yeah, absolutely. And I think you make a good call out there that, these are some of the tools that you do have available to you. SAM, Amplify, CDK, all great tools, but there are also third-party options out there as well. And my title is a partner solutions architect, and so I'm totally comfortable saying, there are great third-party partner options. If this doesn't quite fit your needs, or if you're maybe used to another service already, give them a shot. There are some really great services out there that integrate well with your serverless building. And yeah.
Hey, you mind if I jump in here just because we're getting towards the end of the presentation? And I want to make sure the audience gets a chance to ask a few questions. So this is a great time for you to type in any questions that you want to ask of Taz or me. And then we can get to those here in the last few minutes. But go ahead and finish your presentation while folks are entering those questions.
Yeah, absolutely. We'd love to hear more from you, and to connect as well. But anyway, I wanted to just close with some simple Lambda best practices. First one, limit your function / code size. These are meant to be small, lightweight functions that run, turn off. They're not meant to be long running. Remember that execution is asynchronous, so as you're coding, factor that in. You do have a 500 megabyte temp directory provided to each function, so you're able to store things temporarily that way. Don't assume that a function will reuse underlying infrastructure, but take advantage of it when it does occur. This is kind of a deeper, like 400 level Lambda concept, but basically we create environments to run these Lambda functions in, and each function needs its own environment. After a Lambda finishes execution, we can then continue to use an environment that has already been created, and so there may be some underlying infrastructure that you can take advantage of there, but don't rely on it because you're not always going to have access to that. Going to the next area, you own the logs, so make sure that you're using those, both for your own monitoring process, for debugging, for all kinds of things. Information is power in this case, and I definitely use those logs. And building on that, use custom metrics. So you can totally program custom metrics so that you're able to understand a little bit more about what's going on with your functions.
On those last 2 points, is that CloudWatch where you would do that, or is there a different service?
Yeah, so CloudWatch is where those things are going to go by default, but you could also integrate those things with a third party as well if you have a different monitoring solution that you like. So yeah, CloudWatch by default, but yeah, we definitely have people that build serverless but integrate with other monitoring solutions.
Okay, so we just had a question come in, and basically it's asking if Lambdas are sessionless.
Yes, so sessionless, I assume that by sessionless we mean kind of stateless. And yeah, essentially when a Lambda spins up, it won't have context outside of what you allow it to have access to. And so one of the ways people do that, for example, if you do need to keep track of state, for example, a great way to do that is through something like DynamoDB. So upon invocation of that Lambda, it can then go query this external source of truth to then handle internal logic within the function. And so that's a great call out. If you do want to have session or state type information, it would need to be handled outside of the function itself.
And you also, I'm not an expert in step functions, but step functions can help you along the path of this as well, right?
That would be, yeah, absolutely. That would be the next area that you could also take advantage of that. Step functions, that's one of the big reasons why they were created as well, was so that people could have these more interactivity between functions that run in parallel.
Yeah, effectively the step function pattern is basically a workflow, which has its own state, which is managed by step functions. So, I mean, in a lot of applications, that might be the way to go.
Totally. But yeah, great question. Just keep the questions coming. I'm just going to knock out these last few areas. Use your environmental variables. So what we mean by that is there are some areas that when you're parameterizing your code, there are some environmental level things that you can pass into every single function. And so that could be super useful for you. The way that I use this a lot is if I'm trying to create, a dev test prod type situation, passing in those variables can be super useful for you. From a security perspective, externalize authorization to IAM roles whenever possible. Roles are just going to be more secure for you than having to try and manage a username password type situation. And so, as always, though, if you are using roles, use least privilege. Do not create lambdas that have admin access to everything in your account, because that's just a bad practice. You got to think through it. What does this function need? And a lot of times it's pretty simple. You need access to S3, you need access to Dynamo. Maybe you only need read access to Dynamo and not write. Think through those things as you're going and building these types of things. Kind of covering what we talked about in that previous question, externalize your configuration. DynamoDB is a great option for that. And take advantage of dead letter queues so that you can handle your failed invocations. And so a couple other things that I would like to call out that's not on here is be aware of your service, your throttling limits, and engage AWS support. If you know that your application is going to exceed those limits, file a report with AWS support and get those limits moved up. Contact AWS support before known large scaling events. This is so that we can make sure that we have all of the infrastructure available to you that you need. Black Friday shopping is an example that may come up to my mind is, you may have a plateaued steady amount of traffic and then all of a sudden Black Friday hits. If you know that something like that's going to happen, contact AWS support, just so that we can make sure that we have everything in place for you all.
Yeah, so one last question here. Maybe not the last one, but one more. Maybe we can have time for two. The question was, can we use Lambda as a REST API? And I think the answer is not by itself, but can you explain just real quickly how that works?
Yeah, totally. So not necessarily by itself. Generally, the best practice for that is to integrate it with API Gateway. And so API Gateway it's going to be your best option there because it also scales very, very, very well. And so essentially you would set up your front end to call an API Gateway path that you can define, and then that will transfer everything to the backend Lambda to do the compute function.
Awesome. And then I don't know if this can be answered easily, but the question is, do you consider it a best practice to use Lambda for enterprise solutions?
That is very much an it depends.
Yeah, that's what I thought.
I would say, to change that question a little bit, can Lambda take enterprise level loads and enterprise level demands? Absolutely, it can. Going back to earlier in the presentation, we had some of those examples of scale that we've seen with Expedia, FINRA, Fannie Mae, those types of things. And so these are absolutely large enterprise use cases. And so I think it can be appropriate for enterprise use cases, but the exact workload, it depends.
Yeah, like with most software answers, there's lots of ways to do things, and your situation is going to matter, like which language to choose, which technology to choose in your architecture. I mean, there's so many factors that go into that. There's no one right answer. But as we talked from the beginning, I think serverless and Lambda is a great approach. One thing we didn't even talk about, and I'm going to leave it as something for the audience, is it's a great way to experiment. So you can quickly get some code and out there and test it and try some things. And so don't forget about that aspect of it as well, as it doesn't even have to be your enterprise grade solution, but it's a way to get some code out there and test it quickly.
Yeah, I love that idea. A lot of times, especially in early sales processes, a good POC speaks way better than words do. And that's one of my favorite things to do with Lambda, although it is great for enterprise level type of things. It's also just so fast. And again, you get 1 million free requests per month. So like that's quite a lot. If you have a POC that's doing more than 1 million, it sounds like it's not really a POC at that point.
Yeah, exactly.
But yeah, you can totally POC really quick and bring those types of things to sales types meetings as well. It's so cool to see actual software running as opposed to just a hypothetical conversation.
All right, so we're at the end of time, and Taz, I really want to thank you for taking the time to join us. Here's our contact information. All of this content will be available to you by tomorrow, I believe. Jill can correct me if I'm wrong. You should get an email telling you that it's ready, and you can download it and view it. All this wonderful information that Taz has provided for us. I also want to thank everyone in the audience for joining, and we really appreciate you taking the time to listen to what we have to say, and hopefully you learned and can leverage this going forward.
Yeah, and please don't hesitate to reach out. Both you've got my email address there. Connect on LinkedIn as well is a great place. So we're here. We'd love to hear from you all. And to CenterZip, thank you all so much for having me today.
Yeah, it's been a pleasure. All right, so that's it for today, everyone. Have a great rest of your day. Bye.